Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. My name is Nasaliza Narina binti Losli. My group will present the topic of our project, which is Helicopter Dynamics Control System. The meaning of Helicopter Dynamics Control System is system that easy to control the helicopter. This system designed by us for operating the helicopter dynamics, and we also will determine the gain and phase of system to solve the problem. To increase or decrease overall lift will requires that the controls at the angle of attack for all blades collectively by equal amounts at same time, resulting in ascent, descent, acceleration and deceleration. In our project, we will solve the question that have baud plot, phase margin, gain margin, and also lead lag compensator. Baud plot means graph of frequency response of system. It usually use combination of baud magnitude plot, which is expressing the magnitude of frequency response, and also baud phase plot, which expressing phase shift. Phase margin, difference between the phase and 180 degree for an amplifier output signal at 0 dB gain. Gain margin, it occurs at phase crossover frequency. And the last one is lead lag compensator, component in a control system that improve an undesirable frequency response in a feedback and control system.
Assalamualaikum. My name is Ma'akila Zahira binti Ahmad Zarani. My part is objective. The objective is to make a baud plot of the system accurate and correct by using baud plot. Secondly, measuring dynamic of helicopter rotors is very challenging due to wiring and data transmission problems. Next is to determine gain and phase margin of the system by using baud plot. Lastly is to make a design of compensator, leak or lag, so that the phase margin will be greater than 48 degree.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Nasirah binti Badrun. I will present question A, which is draw the baud plot of the helicopter dynamics and determine the gain and phase margin of the system. The transfer function is given in the slide. The command is from the Scilab software. Firstly, the coding in the slide, the numerator is 50 and the denominator stated in the code. We can conclude that the phase margin is 17.964236. The system is closed loop control system stability. From the table, the magnitude touch 0 dB, and then the phase margin is positive, which is 17.
Assalamualaikum. My name is Nasara binti Tajuddin. I would like to present the question B. The question B asks us to design a compensator which is lag or lead so that the phase margin will be greater than 48 degrees. So, from the previous slide, we can see that the phase margin is equal to 70.96 degree, while the gain compensator frequency is equal to 2.45 Hz. So, from here, we need to find the phase lag network, which is 48 degree plus with 5 degree. 5 degree is the safety margin and we get the first network, which is the 53 degree. Then we find the frequency phase, which is negative 100 and negative 180 degree plus with 53 degree, and we get the final value of frequency phase is equal to negative 127 degree. As we know that the frequency phase is negative 127 degree, we use this frequency phase to find the frequency, which is we adjust the value of frequency phase into the graph, which is here, and we get the value of frequency is equal to 0.59 Hz. We use the value of this frequency and find the magnitude into the magnitude graph. So we adjust until we get this value, which is 0.59 Hz, and the magnitude is 20.61 dB. Based on the figure 2, we can find the omega c, which is from this frequency we convert into the omega c by multiply it with 2 pi. Then 0.59 multiplied by 2 pi is equal to 3.71 radian per second. After that, we find the alpha value, which is 20 log alpha is equal to 20.61 dB, which is the magnitude here. Then we anti-log the alpha. Then we anti-log and get the alpha value, which is 10.73. Next, we find the zero value, which is Z is equal to omega c divided by 10, which is 3.71, the omega c here, divided by 10, and we get the value is 0.371 as the zeros. Then we find the tau value, which is 1 over Z is equal to 1 over 0.371 is equal to 2.6954. After that, we substitute all this value into the general equation, which is 1 plus tau over S, which is 1 plus tau S divided by 1 plus alpha tau S. We substitute the value of tau and the alpha, and we get the final equation, which is 1 plus 2.6954s over 1 plus 2x 0.9216s.
From the calculation, we get new transfer function, and then we using Scilab to confirm the phase margin greater than 48 degree. And the result from Scilab, we get phase margin equals to 48.026. Therefore, the phase margin is greater than 48 degree. This is the graph of the result. As you can see here, the phase margin is increased. Then, this satisfies the objective of this project, which is the phase margin is more than 48 degree.